Hi everyone, welcome back to my channel. This is Mr. Budihas, your online math teacher. In today's video, you will learn how to solve quadratic inequalities. Let's start. Let's learn first what are critical numbers, or otherwise known as critical values. Critical numbers are the roots of the corresponding quadratic equation of the quadratic inequality. For example, given x squared plus x minus 6 is less than 0, the corresponding quadratic equation of this quadratic inequality is x squared plus x minus 6 is equal to 0. We'll just change the sign from the inequality sign, which is less than, we change it into equal sign. So this is now the corresponding quadratic equation. So again, we just change the inequality sign into equal sign. And then after that, we will solve the quadratic equation to get the roots. And that roots, take note, are the critical numbers for the quadratic inequality. Now let's continue this to the next slide. So we have now, this is the quadratic equation or the corresponding quadratic equation of the given quadratic inequality. We will now solve for the roots of this quadratic equation. To find the roots, of course, we'll factor this expression here. The factors are x plus 3 and x minus 2. Then applying the zero product property, we'll equate both factors to 0. So x plus 3 is equal to 0 and x minus 2 is equal to 0. And then we have now the values of x, which is we have negative 3 and positive 2. These are the roots of the corresponding quadratic equation. And that roots are the critical numbers for the quadratic inequality x squared plus x minus 6 is less than 0. Next, we have the test intervals. Intervals into which the critical numbers divide the real number line. This is our number line, and these are the roots, r sub 1 and r sub 2. Let r sub 1 and r sub 2 be the critical numbers of the quadratic inequality where r sub 1 is less than r sub 2. The test intervals are as follows. First, x is less than r sub 1, or we can write it in interval notation from negative infinity to r sub 1. And this is the graph from negative infinity to r sub 1, or the first root. That is the first notation or the first interval. Second interval, we have x is greater than r sub 1 but less than r sub 2. And that is from your r sub 1 to r sub 2. The values from r sub 1 to r sub 2. That is the second interval. And the third, we have x is greater than r sub 2, or from r sub 2 to positive infinity. So we have now completed the number line. And those are the three intervals. From the test interval, we'll get representative in each interval. And that representative is what we call the test number. Test numbers are any number taken from the test intervals and are substituted to the given quadratic inequality, and the purpose is to determine if the interval is a part of the solution or not. For example, given 2 and 8 as the critical numbers of x squared minus 10x plus 16 is less than 0, the test numbers in each interval are as follows. From the interval x is less than 2, the test number could be chosen less than 2, that is 1, 0, negative 1, negative 2, and so on. So we'll just choose 1 for that interval. For the second interval, where x is greater than 2 but less than 8, the test number could be chosen between 2 and 8. For example, 3, 4, 5, 6, and 7. So again, we'll just choose 1 as the test number. And for the third interval, x is greater than 8. The test interval could be chosen greater than 8, or again, this is test number rather. Test number could be chosen greater than 8, and that is 9, 10, 11, and so on. Again, we'll just choose one test number here in this interval. Note that, however, that if the quadratic inequality has no critical numbers or there is no real roots, there will be no test interval. In this case, the test number could be chosen from any set of real numbers, and the solution could only be null set or empty set. Or the set of real numbers is from negative infinity to positive infinity, or the set of all real numbers. Now let's try some examples. Number 1, what are the critical values for the inequality x squared minus 2x minus 15 is greater than or equal to 0? Take note, we are just to find the critical values for this inequality. First thing to do is we are going to treat this inequality as a quadratic equation to determine its critical numbers. We'll get its corresponding quadratic equation. From this inequality, we'll just change the symbol inequality to equal sign. So we have now this corresponding quadratic equation. Then solve for the roots. Solve the quadratic equation to get the critical numbers. Again, the roots of this quadratic equation is what they call the critical numbers. Factor this expression here, and we have x plus 3 and x minus 5. Then applying zero product property, we'll just equate each factor to 0. So you have now x plus 3 is equal to 0 and x minus 5 is equal to 0. Then solve for x. X here is negative 3 and the other side is x is positive 5. The roots of the corresponding quadratic equation are negative 3 and 5. And that roots, take note, is the critical numbers for the given inequality x, this inequality. Again, the critical numbers are negative 3 and 5. Example number 2. Find the values of x for which x squared is greater than x minus 4. First thing to do is we are going to transform the quadratic inequality to standard form when needed. Here we have, this is the given inequality, and we transform it into standard form. X squared minus x plus 4 is greater than 0. And take note, we are going to treat the inequality as a quadratic equation. So we have now this x squared minus x plus 4 is equal to 0. This is now the corresponding quadratic equation. Third, solve the quadratic equation to get the critical numbers. We have, this is the corresponding quadratic equation using the quadratic formula. We have to identify A, B, and C. Our A is positive 1, B is negative 1, and C is positive 4. Then we'll substitute all the necessary values to our quadratic formula, and we have x is equal to 1 plus minus square root of 1 minus 16 over 2. And 1 minus 16 is negative 15. And next square root of negative 15 is imaginary number. There's no such thing that if you are going to multiply by itself twice, the result is negative 15. Square root of negative 15 is an imaginary number. So the quadratic equation has no real roots because this is again this is a complex number or imaginary number. So the quadratic equation has no real roots, therefore there are no critical numbers. And again, if there is no critical number, the test number could be chosen from the set of real numbers. And for our convenience, we'll choose 0. We'll try 0. So substitute the test number to the quadratic equation, quadratic inequality rather. We have 0 squared is greater than 0 minus 4. And 0 squared is just 0. 0 minus 4 is negative 4. 0 is really greater than negative 4. And that is true. Since the test number makes the inequality true, the solution to the given inequality is the set of real numbers. In set notation, that is the set of all x such that x is an element of real numbers. And in interval notation, we can write it in this way. From negative infinity to positive infinity, meaning all numbers are solution. All real numbers are solution. There is no critical number or critical value. Now I'm done with my discussion. Now it's your turn. I want you to solve this individual practice. And please comment your answers below so that I can check also if you are really learning from this discussion. And that's all for today. Thank you for watching.